Okay, so this is the key to test 3. In problem number 1, you're given this function. So this is a quadratic function, and you want to find the function value when x is negative 3. So in place of x, you're going to substitute negative 3. So we see the variable x here, you're going to substitute negative 3. So I get f of negative 3 will be 2 times negative 3 squared minus 3 times negative 3 plus 1. And so negative 3 squared is 9. 9 times 2 is 18. So I get 18. A negative 3 times a negative 3 is a positive 9, and then plus 1. And then when you add these numbers, 9 plus 1 is 10, plus 18 is 28. So f of negative 3 is 28. So when x is negative 3, the y value is 28. Okay, and over here, you want to find the function value when x is x plus 1. Now notice when you substituted a real number, you ended up with a real number. So when you're going to substitute a variable expression, you're going to end up with a variable expression on this side. Okay, so the first thing you have to do is where we see the variable x, you're going to substitute x plus 1. And so I see the x here, and I see the variable x here. So I'm going to end up with something that looks like this. Our first step would be to say 2 times x plus 1 squared minus 3 times x plus 1, and then plus 1. So where we saw the variable x, I substituted x plus 1. All right, now I've got to do a little bit of work here. This x plus 1 squared, I've got to figure this out. So I'm going to go off to the side, and I'm going to write out x plus 1 squared like this. Now remember, x plus 1 squared means x plus 1 times itself. And so I am multiplying two binomials. And so remember, in multiplying two binomials, you can use a FOIL method. So in the FOIL, this is the first times first, so x times x is x squared. The outer, x times a positive 1 is a positive x. The inner, 1 times x is a positive x. And then the last, a positive 1 times a positive 1 is a positive 1. So I end up with, when I combine like terms, and the only two terms that I can combine are the out and the inner here. And so I get x squared plus 2x plus 1. Okay, now that's going to go here. So remember, what I just found here is this part only, this part right here. And so this right here. That's what that is. And so I'm going to replace this with this trinomial. So I get 2 times x squared plus 2x plus 1 minus 3 times x plus 1, and then plus 1. All right, now the next step would be to use distributive property here and here. So I get 2x squared, 2 times 2x is 4x, 2 times positive 1 is 2, and then distribute the negative 3, I get negative 3x, a negative 3 times a positive 1 is a negative 3, and then plus 1. And then all you do now is just combine like terms, and so I get 2x squared. All right, in terms of the variable x, I can add 4x and a negative 3x, and that would give me a positive x. And then your constants, a positive 2 and a negative 3 is a negative 1. A negative 1 and a positive 1 is 0. So all you end up with for f of x plus 1. So when I substitute the variable x, the expression x plus 1 into the variable x into f of x, I get this binomial. So I get 2x squared plus x. All right, now in number 2, you're given this graph. Now notice this is an endpoint right here, and it is closed. It is not open, it is closed. And this is an arrow here, so that means that this part just keeps on going to infinity right here. And so for increasing, remember when you're doing increasing, you're looking at all of these, you're looking at elements from your domain. So elements from the domain. So basically you're going along the x-axis. So as I go along the x-axis, you need to look at what's happening. So remember, this is an endpoint here. So I'm starting here at x equals 6. So at x equals 6, right here. So it sometimes helps if you kind of draw that vertical line to partition your x-axis. So when I go from x equals 6 to x equals 3, I'm sorry, I meant x equal negative 6, excuse me, x equal negative 6 to x equal negative 3 right here, my graph is increasing. So far I know that from negative 6 to negative 3, my graph is increasing. My function is increasing. My y values are increasing. That's what that means. Remember, f of x is y. So my y values are increasing. You can see that your y values are increasing. But as I go from -3, so again, use a ruler, -3 to -1 right here. So -1. So from -3 to -1, my y values are decreasing. My function is decreasing. So I end up with, here, I'm going from -3 to -1. Now also keep in mind, before we go further with this, that when you're talking about increasing, decreasing constants, you are talking about open intervals. All right, so none of these should be closed. So in my math lab, if you put any of these with brackets, it will mark it wrong. It will mark it wrong. These should be all parentheses all the time. These are open intervals that you're dealing with when you're talking about increasing, decreasing constant. And then as I go from over here, as I go from -1 to a +3, my y values are constant. And so I'm going to say -1 to 3. And then as I go from 3 to 4, notice what happens as I go. Well, let's go back here. Notice that these y values are constant, meaning that they're always going to equal 2. That's a 2 right here. And so from 3 to 4, those y values are increasing. So I'm going to say union, right here, union 3, 4. So from 3 to 4. And then finally from 4 to infinity. So notice from 4 to infinity, keeps on going because of the arrow, doesn't stop. So from 4 to infinity, my y values are constant. So union 4 to infinity. All right, so that was that one. Now here, remember the part B, you want to find function values. So basically, remember f of x means the same thing as y. So when you go here, you want to find what the y value is when x is 10. So basically what that means is, what is y when x is 10? When x is 10. So you got to locate when x is 10 what y is. So notice that over here, you may say, well, it stops at 7. There's nothing else on the x-axis, but remember, this is horizontal right here. It keeps on going. So this is 8, this is 9, this is 10. But regardless, all of these y values right here is this y value 4. So these are all 4s. F of 5 is 4, f of 5.7 is 4, f of 6 is 4, f of 6.8 is 4, and so on. So f of 10, when x is 10, my y value is going to be 4. So that's 4 here. Now what this means, same thing. So this is what is y when x equals -2. That's what that means. So what is y when x equals -2? So when x is -2, this is where x is -2. Now you really need to use a ruler here because these grid lines are very faint. So when x is -2, I'm going to get this point here, right here. So when x is -2, my y value is 4. So when x is -2, my y value is 4. All right, now here, this says determine the value of x for which f of x is -6. So remember, f of x is y. So they're saying when y is 6, what is the x value? Well, remember, y is 6 on the y-axis here. So locate the 6 on the y-axis, and then locate the point of the graph that corresponds to it. So this is the point of the graph right here. So if you label that point, this is really -3, 6, -3, 6. And so again, what you're asked is when y is 6, and this is the only point of the graph, no other point of the graph, if you look at any other points, no other point of the graph has a y value of 6. This is the only point of the graph with a y value of 6. So the question is, what's that x value? So what's the value of x? Well, x is -3. All right, so that was number 2. Okay, number 3, basically number 3, you're given these piecewise functions. You're given those piecewise functions, and you are asked to find the function value. So when y, what is y when x is -2? What is y when x is 3? What is y when x is 5? All right, now remember, in a piecewise function, that's where you have 2 or more functions that make up this this function here. Okay, so basically f of negative 2 means I got to figure out which one of these domains here. Now remember, 5x, f of x equals 5x minus 1 if x is greater than 3, and f of x equals 2x plus 7 if x is less than or equal to 3. So you got to locate negative 2. So it's not this one right here, because negative 2 is not bigger than 3. Negative 2 is less than or equal to 3, so it's this one I got to use. So I'm going to use this function here. So in place of x, I'm going to substitute negative 2. So I get 2 times negative 2 plus 7. So negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. Over here, again, this time x is 3. So is x bigger than 3? The answer is no. X is not bigger than 3, but x is less than or equal to 3. The equal part is what we're using here. So I'm going to use this function again. So that's going to be 2 times 3 plus 7. So 6 plus 7 is 13. Over here, this time I'm interested in what's the y value when x is 5. Well, is 5 bigger than 3? The answer is yes. I'm going to use this in here. So this is a function I'm going to use. So I get 5 times 5 minus 1. So that's 25 minus 1, which is 24. All right. Over here, now you're going to graph these this piecewise function here. So remember, when graphing a piecewise function, first of all, notice that this part here where f of x equals x plus 3, remember that's the same thing as y. If x is less than negative 2, remember that's if there was no restriction on the domain, that would be a line. See, these are both linear functions here, but there is a restriction on the domain. So it's not going to be a line with arrows on it, with arrows on both ends, I should say. Is going to be a ray. So you'll be drawing rays here. So you're drawing rays because of this restriction. Now remember, let's do the first one first, that first equation right here, y equals x plus 3. When doing that, though, you have to remember you must use this number right here. So I must use this. So when x is negative 2, I get y equals negative 2 plus 3. So in place of x, I'm substituting negative 2. Negative 2 plus 3 is 1. Now when I plot that point, though, you see there's no equal sign. So when I plot that point, I'm going to have to use an open circle. Okay, now I've got to pick one more number. Remember, draw a ray. I just need 2 points. So I need that end point, which I get from this number here, and it's going to be open because there's no equal sign here. I need one more number that's less than negative 2. So if you say negative 3, I get y equals negative 3 plus 3. So remember, where we saw the variable x, you substitute negative 3. Negative 3 plus 3 is 0. So I get negative 3, 0. So when I graph this ray here, I'm going to get negative 2, 1 is here. Remember, that's an open circle, though. And then negative 3, 0 is here, a closed circle. And do the best you can. If you don't have a straight edge, do the best you can drawing this so you get something that looks like this. All right, so there's your ray. It does have an end point that's open. All right, and let's do the next one. So now we're going to graph y equals x minus 1. Now to graph this one, my domain is restricted. I can only use a domain. I can only use a number for x that's greater than or equal to negative 2. So when I use my t-table, I have to use negative 2. So when x is negative 2, remember you must use these numbers. So when x is negative 2, I get y equals, in place of the x, I plus substitute negative 2, so negative 2 minus 1, which is a negative 3. Now remember, we had to determine whether that endpoint, so these are your endpoints, we have to determine whether that endpoint's open or closed. Since there is an equal sign, this is going to be a closed circle. So be closed. All right, and then I just need one more point, so be here. So negative 2, negative 3 is here. So I just need one more point to graph this ray. Now remember, I got to pick a point that's bigger than negative 2, greater than or equal to negative 2. So let's say 0. If x is 0, I get y equals 0 minus 1. So again, in place of x, you substitute 0. So 0 minus 1, which is a negative 1. So 0, negative 1 is here. And then again, just use a straight edge to graph this. So when you graph this, you're going to get something that looks like this. All right, and there's a graph. So this graph is made up of two rays because these are linear functions right here. Now they're rays because your domain's restricted. The domain's restricted. All right, so that's number 4. Number 5, you're going to use this graph to answer these questions. All right, so remember, this is a quadratic function, so this is a parabola. Now, when you look at domain, you go from you go along the x-axis. Now, when I go along the x-axis, you need to notice that this arrow indicates that this graph keeps going down like this. All right, and the same thing here, keeps going down like this. But as you go from, for instance, if I look at -5, if when x is -5, am I going to get a point on the graph? Sure, I will. It's going to be way down here. Same thing here. So if I use -1000. If x is -1000, I can get a point on the graph. Will there be a y value associated with -1000? Yes, there will be. -1,000,000 and so on. So basically, for the domain, I'm going from -infinity all the way to +infinity. All right, so from -infinity to +infinity. So that's your domain. All right, now the range. Okay, for the range, you had to first of all denote what this vertex is. So this vertex right here is 2, 4. That's your vertex. So you needed to see what that was. So that's 2, 4. All right, now for the range, see how these arrows, both arrows are pointing down. So, and when finding the range, you go along the y-axis. So I'm going from, so this is -100. Am I going to get a point in the graph? Yes. I'm going to get a point here and a point here. So we get y values on that graph. And so I'm going from -infinity all the way to, and then when I go on the y-axis rather, I stop here. And the question is, what is this y value right here? Because remember, I'm finding range. The range is a set of y coordinates. So the y value here is 4. And so when you do this, you can say -infinity to 4 with a bracket, not parentheses, bracket, because 4 is a y value on the graph. So every real number for y, let's say -2. So there's a -2 here and a -2 here. -1 here, -1 here. -0.6 here, +0.6 here, +0.6 here, and so on. In fact, the largest y value you will get will be 4. There's no y value 5. Notice that if you look at any point in here, there's no y value that's a 5. The largest y value you see is a 4. So that's what this implies. Okay, x-intercepts. So remember, the x-intercept is where the graph crosses the x-axis, and it crosses the x-axis twice. So here and here. So if you want to label the x-intercepts, you can do it one of two ways. You could say, well, the first x-intercept is 0, and the other x-intercept is 4. Or you can label these as ordered pairs. So you can say 0, 0, comma, 4, 0. The y-intercept, remember, that's where the graph crosses the y-axis. It crosses the y-axis here. So that y-coordinate, see, this is y-coordinate 1, this is y-coordinate -1, this is y-coordinate 0. So that's 0 as well. Or you can say 0, 0, which is the origin. 0, 0, remember, represents the origin. Okay, f of 1, just like before, means what's the y value when x is 1. So I got to locate the point of the graph where the x value is 1. So is the x value 1 here? No. Is the x value 1 here? No. The x value, see, this is 1. So when you go straight up like this, that's the point of the graph. This right here is a point of the graph where x is 1. In fact, when x is 1, my y value is 3. And so now I can answer this question. So the question is, when x is 1, what's the y value? Well, the y value is 3. Okay, now the intervals where the function is increasing, well, remember, you got to go along the x-axis for that. That's where you use your domain. So as I go from -infinity, notice the y values. As I go from -infinity to, and notice these y values are increasing. They're increasing, and then all of a sudden they're decreasing. So as I go from -infinity to x equal 2, my y values are increasing. As I go from 2 to infinity, my y values are decreasing. All right, so you can say increasing from -infinity to 2 and decreasing from 2 to infinity. All right. Now, a mistake people make is that they use the y value, so they say negative infinity to 4. That's not what you use here. Remember, you got to use values from your domain. All right, so you got to use numbers from your domain, elements from your domain. So you got to go along the x-axis. So from negative infinity to x equal 2, the y values are increasing, and from 2 to infinity, the y values are decreasing. So basically, you're asking yourself, I need values for x where the function is increasing. So the function is increasing from negative infinity to 2. And then the values of x where it's decreasing. Well, it's decreasing from 2 to infinity. All right, now here, it's asking you when y is 4, remember f of x is 4. So when y is 4, what's the x value? So basically, you got to look, hey, where in the graph is the y value 4? And so you ask yourself, well, is it here? Is that y value right here 4? No, that y value is 1. Is this y value right here 4? No, that y value is 2. Is this y value right here 3? No, I'm sorry, 4? No, the y value is 3. So notice, though, you have it already here, right here. So when the y value is 2, the question is, what's the x value? What's the x value? So what the x value where the y value is 4? Well, the x value is 2. That goes there. All right, is a function even, odd, or neither? Remember, even function is where the graph is symmetrical about the y-axis. The graph is not symmetrical about the y-axis. And the odd function is where the graph is symmetrical about the origin. Notice the graph is not symmetrical about the origin either. So this is neither. Okay. Now, number 6, you want to find the difference quotient for this function. And so the formula for difference quotient is already listed down here. And remember, you got to really do this in steps. You got to find that f of x plus h first. So first thing you got to do is find f of x plus h. And so basically you're going to say, well, that's going to be 3 times x plus h squared. So wherever you see the variable x, you're going to substitute x plus h, the expression x plus h. So minus 4 times x plus h, and then plus 1. Now we've got to figure out what this part is right here. Just like a while ago when I figured out what this was here, that's right here, x plus 1 squared, you got to do the same thing here. So remember, we went here and figured out what x plus 1 squared was, or is. So you got to do the same thing here. So I got to figure out what x plus h squared is. Well, x plus h squared means x plus h times x plus h. And so you're going to get x times x, which is x squared. The outer is xh. The inner is xh. And then h squared. H times h is h squared. So then you get x squared. So that's 2xh. Because xh plus xh is 2xh. And then h squared. Now that goes here. So that's going to be 3 times this trinomial here. So that's x squared plus 2xh plus h squared. And I'm going to go ahead and distribute this now. So that's minus 4x minus 4h, and then plus 1. Now distributing here, I'm going to get 3x squared. 3 times 2xh is 6xh. And then 3 times h squared is 3h squared. And then minus 4x minus 4h plus 1. And remember, none of these you can combine. They're all different terms. None of them are like terms. All right, now the next step is this. So now we're going to find this difference quotient now. So we're going to find f of x plus h minus f of x divided by h. So we already found this. That right here is this. So I get 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 1. Remember, that is this. But then I got to subtract the function. So I got to subtract, and you got to put the function in parentheses. So that's 3x squared minus 4x plus 1. All that's being divided by h. So remember, those are the steps you got to show. Now let's go ahead and distribute the negative 1 through here, or add the opposite of this. So I get 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 1, that's an h here, minus, and then when I subtract a positive 3x squared, I get a negative 3x squared. When I subtract a negative 4x, I get a positive 4x. And when I subtract a negative 1, I get a negative 1. All over h. That was minus right here. Okay, now at this point, this is where the terms, any term that does not have a factor of h, its opposite better be located somewhere so these can cancel out. See, this term here has no factor of h. So its opposite better be located somewhere, and it is. It's right here. So that means that 3x squared and a negative 3x squared is 0. This has a factor of h, it stays. This has a factor of h, it stays. This does not. So its opposite better be located somewhere. Negative 4x and a positive 4x is 0. This has a factor of h. This does not. So a positive 1 and a negative 1 is 0. Now the only terms left, notice all these terms that are left have a factor of h. All these terms that are left has a factor of h. And so I'm going to factor out an h from those three terms. So basically I'm going to end up with h times 6x. So make sure you see this. H times 6x is 6xh. Plus h times 3h is 3h times 3h is 3h squared. And don't forget this one, minus 4. H times a negative 4 is a negative 4h. All over h. And now I can divide out these h's, and you're left with 6x plus 3h minus 4. And that's your answer. 6x plus 3h minus 4. All right, number 7. Okay, number 7, you just wanted to determine the slope of the line. So remember, the slope formula is y2 minus y1 over x2 minus x1. And it does help if you label these. So let's call this x1, y1, our first point. And the second point, we're going to label this x2, y2. And then we just substitute these numbers back into this formula. So y2 is negative 3, so I'm going to say the slope will equal negative 3. Subtract y1, which is a negative 5, divided by x2, which is 5, subtract x1, which is negative 2. So this becomes negative 3 plus 5 over 5 plus 2, and negative 3 plus 5 is a positive 2. 5 plus 2 is 7. Now again, if you don't remember your rules from several semesters ago about signed numbers, use your calculator. So that's 2 7ths. So the slope is 2 7ths. Okay, over here you want to graph this line using slope and intercept, y-intercept. Okay, well, first of all, notice that this is already in slope-intercept form. So this is slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And so the number you're multiplying x by is called the slope, and the constant is your y-intercept. Remember, the y-intercept is where the graph crosses the y-axis. So the slope here is a negative 2/3. And the y-intercept is this constant, which is 3. Remember, that's the y-intercept here, not the x-intercept, the y-intercept. And you want to graph this, you've got to follow the directions. It says using the slope and y-intercept. Do not use the t-table and plot any other point to draw this line. You must use this information only. So remember, to graph a line, you need 2 points. Well, you already know one of them. You know this point here. That's the y-intercept. So the y-intercept is a positive 3. So that's here. So that's the y-intercept. Now I'm going to use, to find the other point, remember to graph a line, you need 2 points. I'm going to find the other point. So remember, the slope is rise over run. And my slope here is negative 2/3. So my rise is a negative 2, and my run's a positive 3. So from this y-intercept, I'm going to go down 2 because that's my rise. It's negative. So down 2, 1, 2 units. So down 2 units. And then my run is positive 3. So I'm going to go down 2 units and then to the right 3. 1, 2, 3. And so there's your other point. And so you just draw your line, and there's your graph. Now, remember, the slope is negative. So if you draw a line that's rising, you know you did something wrong because the line should not rise. The slope is negative. This is a negative slope, so the slope better be falling, and it is here. All right, so always keep those things in mind. It does help to see if possibly what you have doesn't make any sense. So if you have a graph that's rising, that doesn't make any sense because that slope is negative. A negative slope, the line of a negative slope, falls. It does not rise. Okay, number 9. Okay, number 9, they want you, so you're given this equation. This is a linear equation. So this is a linear equation. So you're given this linear equation, and they want you to put it in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. And so all you got to do is you get the variable y by itself. So you have negative 3x plus y plus 2 equals 0. And so I'm going to add 3x to both sides and combine like terms. That's 0 here. So I get y plus 2 equals 3x. And then the next thing I'm going to do to get y by itself is subtract 2 from both sides, and then combine like terms. I get y equals 3x minus 2. So that goes here. So y equals 3x minus 2. So the slope is a positive 3, and the y-intercept is a negative 2. That's the y-intercept, negative 2. And then you're going to graph it just like you graphed this one. So you can use that same information that you did here. Okay, so we're going to remember to graph a line. I need 2 points. So I know the y-intercept. The y-intercept is negative 2, so I'm going to put a dot here. I'm going to label it, or actually just put a dot. And then the slope, remember the slope is rise over run. So the slope here is 3, so that's the same thing as 3 over 1. So my rise is positive, my run is positive. And notice the slope is positive, so your line better rise this time. So line has to rise this time. So from this y-intercept, I'm going to go up 3, 1, 2, 3, and then to the right 1. So there's the other point, and when I draw this, I do get a line that rises. And don't forget to draw arrows. You must draw arrows. Okay, now here in number 10, you want to write the equation of the line, and you want your answer in slope-intercept form. Well, remember to start this out, you're going to use point-slope form. So you want to write enough information to use point-slope form. So remember, point-slope form is y minus y1 equals a slope times x minus x1. That's point-slope form. Now remember, in order to use this point-slope form, you've got to know the slope and a point on the line. I do know a point on the line. In fact, I know 2 points on that line. The problem is I don't know the slope. So we got to find the slope first. So the slope, just like we did in the previous problem, just like we did here, the slope, just like this. So the slope is y2 minus y1, y2 minus y1 over x2 minus x1. And so label these x1, y1. Then this second point will be labeled x2, y2. And so the slope then would be negative 3, subtract a negative 4, divided by x2 is 1, subtract a 3. So that becomes negative 3 plus 4 over, and then 1 subtract negative 3 is negative 2. So that's and then negative 3 plus 4 is 1, so that's a negative 1/2. So the slope is a negative 1/2. Now, so I found the slope, and all I got to do is just use one of these points. It does not matter which point you use, you'll still get the same answer. So if you use the first point, so if you want to use, let's say you want to use 3, negative 4. So I'm going to get y minus the y coordinate of my points, that's negative 4, equals the slope, which is a negative 1/2 times x minus 3. So y minus y1 equals the slope times x minus x1. All right, now you need to rewrite this. Y minus negative 4 is y plus 4 equal, and then over here I'm going to distribute this. So I'm going to get, well, before I do that, let me just remind you about something. So this right here, so they ask you to put the answer in point-slope form. This is point-slope form right here. This is the answer you would give. So don't use this one because you need to realize that y subtract negative 4 is y plus 4, so that's the one you would use. Okay, now distribute, and so I get y plus 4 equals negative 1/2 times x is a negative 1/2 x, and a negative 1/2 times a negative 3 is a positive 3/2. Negative 1/2 times 3 is a positive 3/2. Make sure you see this. Remember, negative 1/2 times 3. That's 3 over 1. So negative 1 times 3 is a negative 3. 2 times 1 is 2. So you get negative. Negative 3/2. But it, oops, okay. That should be negative here, so that's positive. So a negative 1/2 times a negative 3 is a positive 3/2. All right, now the next thing you're going to do is subtract 4. So because you got to get y by itself. You got to put in slope-intercept form, so you got to get y by itself. So when I subtract 4, I get 0 here, so that's y equals negative 1/2 x. Now, if you don't remember how to add fractions and whole numbers and such and so forth, use your calculator. So you're going to say a positive 3/2 and a negative 4. So a positive 3/2, so you're going to say 3 divided by 2, subtract 4 equals, and you get negative 2.5. All right. Now don't leave it as a decimal. You got to leave it. You got to rewrite it as a fraction. But if you don't remember that negative, let me put this here. If you don't remember that negative 2.5, you really should know this is negative 2.5. Negative 2.5, negative 2.5. And then rewriting this as a improper fraction, 2 times 2 is 4 plus 1 is 5. This is negative 5/2. So that's what goes here. So that's negative 5/2. But if you didn't know that, all you had to do is just use your function here. So you see where it says f to b right here? That's purple, right above b or b, right here. So to get 2, you're going to press second, and then press this, and then press equal. So you're going from fraction to decimal, decimal to fraction, and so you get negative 2 and 1/2. That's what this was. And then you just got to change that back to an improper fraction. So then your answer is y equals negative 1/2 x minus 5/2. Okay? Now, it did not matter. Remember, it does not matter which point you use. So I got this answer. I got this answer using this point. So if you wanted to use the other point, 1, negative 3, you will still get the same equation here. So you get y minus the y coordinate, which is negative 3, equals the slope, which we said was negative 1/2, times x minus 1. Now remember, y subtract negative 3 is y plus 3, equals negative 1/2 times x minus 1. Now distributing, I get y plus 3 equals negative 1/2 x, and a negative 1 times, a negative 1/2 times a negative 1 is a positive 1/2. And then when you subtract 3, that's subtract 3 right here. Subtract 3. When you subtract 3, you're going to get y equals negative 1/2 x, and then 1/2 and a negative 3 is a negative 2.5, which we know now is negative 5/2. Okay? So it did not matter which point you used, but you did have to first of all find the slope, and then take one of those points and put it back into the point slope form, and then get y by itself. Okay, number 11. Okay, number 11, you want to find the equation of the line that passes this point and is perpendicular to this line that has this equation. Well, so remember, you're looking at two lines basically. You're looking at this line and you're looking at this line. The line I'm interested in finding the equation of goes to this point. And remember, in order to use point slope form, we have to use point slope form here. In order to use point slope form, which is y minus y1 equals the slope times x minus x1. In order to use that form, I've got to know the slope of my line. So the slope of the line I'm interested in, all I know is that it goes to this point. So this is your x1 and this is your y1. That's all you know. You got to find the slope. Well, you do know that the line that you're interested in is perpendicular to this line. And so the slope of this line right here is 4. The slope of this line is 4. Well, remember, if two lines are perpendicular, their slopes are negative reciprocals of each other. So this is 4. The slope of the line I'm interested in, the slope of this line here, it then is going to be the reciprocal, which is reciprocal 4 is 1/4. But then you take the opposite, because remember, it's negative reciprocal. So if this is positive, this becomes negative, the reciprocal. So negative 1/4 is the slope that I'm interested in. So now I know the point and I know the slope. So now I can put it back into the point slope form. So y minus y1, which is negative 1, equals the slope, which is negative 1/4, times x minus 4. So y minus y1 equals the slope times x minus x1. Y minus a negative 1 is y plus 1. Distributing this, I get minus 1/4 x. Now notice this right here, a negative 1/4 times a negative 4, which is negative 4 over 1. Negative 1, remember, negative times a negative is a positive, so negative 1 times 4 is negative 4 is 4, 4 times 1 is 4. 4 divided by 4 is 1. So that's just a positive 1 here. Now to get y by itself, remember you want your answer in slope-intercept form. So you're going to get, so you subtract 1, and so you get y equals negative 1/4 x, and that's 0 right here, and that's it. So y equals negative 1/4 x. Okay, now number 12. Okay, so number 12 is where you're going to start using transformations. And so you have this function right here, g of x is negative square root of x plus 3. And they want you to, first of all, determine what the parent function is for f of x. So remember, this is a square root function, so my parent function is just the square root of x. That's your parent function. All right, now they want you to discuss the transformations. So there's only two things occurring here. Remember, this negative right here is a reflection about the x-axis, and then this 3 that's underneath the radical, remember, that's where it's shifted horizontally. If the 3 was on the outside, it'd be shifted vertically. All right, so since it's inside the function, inside the radical, it's going to be a horizontal shift. And remember, if it's horizontal, it's counterintuitive. So it's not 3 to the right, it's actually 3 to the left. But you got to use mathematical terms for this. You can't just say flip and things like that. Don't use those words. You have to say, first I'm going to take x squared, take the square root of x, and I'm going to shift it horizontally. Shift horizontally to the left 3 units. Don't say 3 times, you must say units, 3 units. Then we're going to do the reflection. So then I will reflect it. And when I say it, I mean the transformation that you just did. So this transformation that's now 3 units to the left, I'm going to reflect it. So then I reflect it about the x-axis. Okay? All right. So now the next part says you want to graph both f of x and g of x. So f of x is your square root function. So remember when graphing the parent function, you use certain points for x. So remember, this is square root though, so I can only take the square root of a positive number of 0. So if x is 0, the square root of 0 is 0. If x is 1, remember these are the numbers we used. So if x is 1, the square root of 1 is 1. If x is 4, we used perfect squares for the square root function. If x is 4, the square root of 4 is 2. If x is 9, the square root of 9 is 3. So when I graph the parent function, I get 0, 0, 4, 2, 1, 1, I forgot about the 1, 1, and then 9, 3, which is here. So this right here is f of x. That's your f of x function. And then just think about what's happening. Okay, now notice how I'm going to motion this with my pen. So according to the transformation you just talked about, I'm going to take each of these points here, and there's 4 points that we just plotted. So I'm going to take each of these points and I'm going to use the transformations on it. So the first point here that I'm pointing to says, first I've got to shift it horizontally to the left 3 units. So notice what I'm doing. 1, 2, 3. Then I'm going to reflect it about the x-axis. Well, it is on the x-axis, so there's no reflection. It stays there. So there's my point there. Then I'm going to take this point here. I'm going to go 3 units to the left. 1, 2, 3. And then I'm going to reflect it about the x-axis. So notice, I'm reflecting by the x-axis. See this? So reflecting by the x-axis. So this is 1 unit above the x-axis. I go 1 unit below. Just like that. Then here I'm going to go 3 units to the left. 1, 2, 3. Then reflected about the x-axis. See, this x-axis is here. Reflected about it. So see how this point right here, when I went 3 units to the left, 1, 2, 3, how this is 2 units above, so I'm going to go 2 units below. 1, 2. So there's the other point. Same thing here. 3 units to the left. 1, 2, 3. And you see how it's 3 units above? You go 3 units below. 1, 2, 3. And so now you get this curve. You get something that looks like this. Oops. Get something that looks like this. Okay? All right, so there's, this is g of x right here. All right, so that's number 12. Okay, number 13. All right, 13, you're also going to do a transformation here. So this time, though, it's quadratic. And so the parent function here is going to be x squared. And then your transformation, so there's no reflection because this is positive here. This number right here is positive. But there is a horizontal shift and a vertical shift. Now remember, you must always do the vertical shift last, especially if there's a reflection. Always do a vertical shift last. So we can do a horizontal shift first. So the first thing we do is I'm going to take x squared and then shift it horizontally to the, and then see how it's plus 3? You can do the opposite, which you would think. So you go to the left 3. So to the left, 3 units. Then I'm going to shift it vertically down. So then shift vertically down. Two units. Okay? Alright, so the thing you got to do though is you got to graph your parent function first. So remember x squared. So you're graphing x squared. So remember what we did was use these points here 0, 1, 2, -1, -2. Those are the points we used to graph y equals x squared, these 5 points. So when x is 0, 0 squared is still 0. When x is 1, 1 squared is still 1. When x is 2, 2 squared is 4. Now be careful, when x is -1, a -1 squared, meaning -1 times itself, is a positive 1. When x is -2, a -2 times itself is a positive 4. So when you graph that parent function, the quadratic function, you get 0, 0, 1, 1, -1, 1, 2, 4, a -2, 4. If you want to go further, you could say -3, positive, let's do positive 3. Positive 3, 3 squared is 9, and the reason you can go further is because there's enough grid lines here. So 3, 9 is here, just like this, and then -3, 9 would be here. Okay, so you use -3, you also get 9 because a -3 times itself is 9. Now the problem is that when you draw your curve, you got to make sure it's a curve. It looks like a parabola. It must look like a parabola. Now don't stop there. You got to draw your arrows. You must draw your arrows. All right. So this right here is f of x. Okay. Now I'm just going to use these 5 points to do the g of x. Okay. So according to this, I'm going to shift all these 5 points right here. All these 5 points, 3 units to the left, and I'm going to shift it 2 units down. All right. So here's what you do: 3 units to the left. So let's go to the vertex first. 1, 2, 3, and then down 2 units. 1, 2. Let's look at this point here. 1, 2, 3, down 2 units. 1, 2. This point here. 1, 2, 3, down 2 units. 1, 2. This point here. 1, 2, 3, down 2 units. 1, 2. This point here. 1, 2, 3, down 2 units. 1, 2. And so now I get this graph right here. Okay, and so this is g of x. That's g of x. All right, now, so number 14, all you want to do in 14, first of all, notice that this is quadratic, and this is in standard form. This is in standard form, meaning this. Remember, another word for standard form is at vertex form. So it looks like this: y equals a times x minus h squared plus k. All right, so where hk is your vertex. All right, and then we want to find the vertex. So remember, it's got to be x minus. If it's x plus, you remember we talked about it. If it's x plus, if this was x plus 2, you first of all need to rewrite as x minus a -2. So this is x minus 2 though, so h is just 2, and then k is 1. So your vertex is 2, 1. And remember, in your mind, that's what you're thinking about. So really a rough sketch of this, just in your mind, this is what you're thinking. So this is 2 1s here. And see how this is negative right here? A is negative, so that means your parabola opens down. Opens down since A is negative. And here's your axis of symmetry. And remember, the axis of symmetry is a vertical line. You have to name the vertical line just like you name a vertical line: x equal 2, x equal 5, x equal -6, and so on. X equal. And notice this vertical line crosses the x-axis at, and remember this was 2, 1, so across the x-axis at 2. So the axis of symmetry is x equal 2, so you must say x equal. Not just 2, x equal 2. It's a vertical line. You're naming a line. So remember, since the parabola goes down, remember A is negative. Since A is negative, the parabola opens down. This vertex is going to be a maximum. So that's a maximum. So this is maximum. And then when we talk about what is that maximum value, we're talking about what is the y value of the vertex. Y value of vertex. That's what we're asking. So the y value is 1. All right, that's number 14. Okay, 15. Okay, you're still dealing with vertex form, standard form. The vertex this time, now remember, I'm going to go ahead and write this here. This is f of x equal x plus 3 squared minus 7. So you need to rewrite this. In your mind, this is what you're saying. This is x minus a negative 3. So this is h right here. And then this is k. So my vertex is negative 3, negative 7. And remember, the axis of symmetry goes through the vertex, and it's the x equal the x coordinate. So this is x equal negative 3. All right, now remember, in your mind, this is what you have. You have this in your mind. So my vertex is negative 3, negative 7, so it's in the third quadrant. My parabola, see how this quadratic, a is 1. So since a is 1, since a equals 1, which is positive, the parabola opens up. It opens up. So I'm going to do this. Okay? And so the domain, remember that this is quadratic function, so the domain is going to be all real numbers, so negative infinity to infinity. Now the range, remember, you're going from along the y-axis. So and remember the vertex here is negative 3, negative 7. So you start touching the graph at what y value? You are talking about the range, so the range set of y coordinates. So what is this y value right here? That's where you start touching this graph. Well, the y value is negative 7 all the way to infinity. So bracket negative 7 to infinity. And the y-intercept, to find the y-intercept, remember you're going to let x equal 0. So to find the y-intercept, you let x equal 0. So when you let x equal 0, notice what happens. I get, remember f of x is y. So I get y equals 0 plus 3 squared. So remember, to find the y-intercept, you let x equal 0. So I get 0 plus 3 squared minus 7. 0 plus 3 is 3. 3 squared is 9. And 9 minus 7 is 2. So the y-intercept is 2. So that's where the graph crosses the y-axis. Okay, now we got to find the x-intercepts. And then it says round to nearest tenth if necessary. Show your work. All right, to find the x-intercepts, I have to let y equal 0. So remember, f of x is y. So that means this whole thing here, I have to set equal to 0. So in other words, x plus 3 squared has to equal 7. I'm sorry, minus 7 has to equal 0. So x plus 3 squared minus 7 has to equal 0. All right, now I got to solve this quadratic equation. So remember, in a previous lesson a while back, to solve for x here, the easiest way is to use the square root property. That's the easiest way to solve for x here. But to do that, I got to bring this negative 7 to the other side. So I'm going to add 7 to both sides. And so I get x plus 3 squared equals a 7. Now at this point, this is where you take the square root of both sides, because right now, remember, I'm trying to solve for x. Right now I'm squaring this binomial, so I got to undo the squaring. So to undo, you take the square root. But remember, you got to do the plus and minus, so don't forget the plus and minus. So there's going to be 2 x-intercepts here, not 1, but 2. And then it says round to nearest tenth. So when I take the square root of x plus 3 squared, the square and the square don't do each other, so I'm left with x plus 3 equals plus and minus the square root of 7. And this is where you would actually split it apart. You would say x plus 3 equals the square root of 7, x plus 3 equals negative square root of 7. And then let's approximate the square root of 7, because it says round to nearest tenth. So the square root of 7 is to the nearest tenth, looks like 2.6. So 2.6. So we say x plus 3 is approximately equal to 2.6. And then to get x by itself, I subtract 3. And so x is approximately equal to, so there's one of your x-intercepts right here. So 2.6 subtract 3, so that's about 0.4, negative 0.4. All right. Now if you had used a whole function, the whole number for square root of 7, let's say square root, let me redo this. So the square root of 7, and some of you may do that, so you get this, and then subtract 3, you get this. But now, so notice to the nearest tenth to the nearest tenth, negative 3.5 is still negative 0.4. Okay? So you still get negative 0.4. Over here, x plus 3 is approximately equal to negative 2.6. And then subtract 3, I get x is approximately equal to negative 5.6. All right, now if you had used the square root of 7 without rounding that off, let's see what happens. But it's negative though, so let me go ahead and redo this. So it's negative square root of 7, close. So negative square root of 7 equals, and then minus 3, and you get this. So that's still negative 5.6 to the nearest tenth. So negative 5.6 to the nearest tenth. All right, so then we're going to use all this information to graph. So now we know the vertex. So the vertex is negative 3, negative 7. So negative 3, negative 7 is right here. Right here. Right here. And then we're going to draw, remember it says show the axis of symmetry. So I'm going to show the axis of symmetry. So here's my axis of symmetry. I'm going to use the axis of symmetry to draw a symmetrical graph. The y-intercept is 2. So here's my y-intercept right here. Now notice, so if the y-intercept is 2, that's 3 units to the right of the axis of symmetry. So I'm going to go 3 units to the left. So here's another point then. So this would be another point on the graph. Right? Another point on the graph. And then all I got to do now is just graph the x-intercepts, and then I can draw my graph. So negative 0.4 is about here, and negative 5.6 is about here. And just make sure when you do the x-intercepts that it does look symmetrical about the axis of symmetry. So that distance does look about the same as that distance. All right, and then you just do the best you can with graphing these. Make sure it does look like a parabola. It does look like a curve. All right, so do the best you can, something like this. All right, and so there's your graph. Okay, number 16. All right, this time this is in general form. All right, and so to find the vertex, you are going to have to use the vertex formula. And so remember, to find the vertex that's in general form, in terms of hk, the h here is negative b over 2a. So that's how you find the x-coordinate of the vertex. So that's the x-coordinate of the vertex. All right, and then remember, this is general form, so you got to find a, b, and c. So a is the coefficient of x squared, so that's negative 1. b is the coefficient of x, that's negative 4. And c is your constant, so that's 2. And so to find the vertex, to find the h-coordinate, I take the opposite of b. Well, if b is negative 4, the opposite of negative 4 is a positive 4. So h would be a positive 4 divided by 2 times a. a is a negative 1. So I get 4 divided by negative 2, which is negative 2. So that's the x-coordinate of my vertex. So that's what I just found. To find the y-coordinate, I've got to say f of negative 2. So I got to find f of negative 2. So f of negative 2, wherever we see the variable x, I plug in negative 2. Now you got to be careful with this because that's negative x squared. So that becomes negative, in parentheses, negative 2 squared. See how that looks? Negative x squared, so negative x squared, minus 4 times x, which is negative 2, and then plus 2. All right, now, you got to follow the order of operations. I got to do exponents first. Negative 2 times itself is a positive 4, but this becomes a negative 4. Negative 2 times of negative 4 is a positive 8, and then plus 2. So negative 4 plus 8 is a positive 4, plus 2, which is 6. All right, so my vertex is negative 2, 6. All right, so in my mind, this is what I have. I have this parabola that's going to look something like this. I found the vertex, negative 2, 6, so that's in the second quadrant. Since a is negative, see a is negative 1, which is negative. So which is negative. Since a is negative, that implies that the parabola opens down. That's what a tells you. A tells you whether it opens down or up. So it opens down. So I am going to get some x-intercepts. I'm going to have to find those. All right, but I can also, right now, determine the axis of symmetry. The axis of symmetry goes to the vertex. It's a vertical line, so you have to say x equal. And it goes, and the x equal, that number you use, it has to be the where the graph crosses the x-axis, so that's -2. Now remember, the axis of symmetry is a vertical line, so every point of that line, if you look at every point of that line, the x-coordinate is -2. The domain, this is quadratic, so the domain is going to be from -infinity to infinity. It's all real numbers. Now the range, you've got to be careful with. So that's where you're going to go along your y-axis. So remember, the arrows are pointing down. So as I go along the y-axis, I'm going from -infinity to this maximum y value right here. And that the coordinates of the vertex is -2, 6. And so maximum y value is 6. So you say -infinity to 6 with the bracket. The y-intercept, that's where you let x equal 0. So when let x equals 0, I get y equals, remember f is the same thing as y. So if x is 0, I get -0 squared minus 4 times 0 plus 2. Well, I want you to notice that all of these right here, these two, that -0 squared is still 0, -4 times 0 is still 0, and all you're left with is your constant c, which is 2. So in finding the y-intercept, if it's a general form, it's just c. Your y-intercept is c if it's in general form. Now don't overgeneralize and say that the y-intercept here is -7. That's not true, because that's not general form. So you actually had to do some work. Remember, all this work right here you had to do to find the y-intercept. Okay, now we've got to find the x-intercept. To find the x-intercept, you're going to let y equal 0. So let y equal 0. So I'm going to set all this equal to 0. So I'm going to get -x squared minus 4x plus 2 equals 0. And that's when I'm going to use the quadratic formula. So use the quadratic formula. All right, and so when you use the quadratic formula, I'm going to get, remember, a is -1, b is -4, and c is 2. So the quadratic formula, remember, is -b plus or minus the square root of b squared minus 4ac all over 2a. So I get x, remember, these are your x-intercepts. You get x equal the opposite of b. Well, b is -4. The opposite of -4 is 4. Plus or minus the square root of b squared. So that's -4 squared minus 4 times a. A is -1 times c, which is 2, all over 2 times a, and a is -1. So I get 4 plus or minus the square root of -4 squared, 16. All right, now a -4 times a -1 times a +2 is a +8, all over -2. Then simplifying the radicand, so 16 plus 8 is 24. 4 plus or minus the square root of 24, all over -2. Now, don't worry about simplifying the square root of 24. Leave it alone, because all you're interested in is what are these approximate x-intercepts. So you just use your calculator. So just at this point, use your calculator. So you're going to say 4 plus the square root of 24, whatever that is, you're going to divide by -2. Then you're going to say 4 minus the square root of 24, whatever that is, you're going to divide by 2. So notice how we do this, though. So in your mind, you're going to say 4 plus, so 4 plus square root of 24. So 4 plus, all right, 4 plus the square root of 24, close the parentheses, press equal, and then that's the numerator, which you just found was the numerator. So then you can divide by -2, press equal, and so that comes about -4.4 to the nearest tenth. All right, the next one, you're going to say 4 minus the square root of 24. So 4 minus the square root of 24, close the parentheses, then press equal, and so that's the numerator. Divide by -2, I get a +0.4. All right, so those are your x-intercepts. All right, so let's plot these important points. So -2, 6 is the vertex, so that's going to be -2, 6 is here. Here's your, remember it says show the axis of symmetry. So here's the axis of symmetry. All right, and then I'm going to use the y-intercept of 2. That's right here. And remember, if you use the idea of symmetry here, so if this y-intercept is 2 units to the right of the axis of symmetry, then the other point on the graph will be 2 units to the left. So these are symmetrical. All right, and then 0.4 is here. That's your x-intercept, and then -4.4 is about here. Just make sure that the x-intercepts look symmetrical, and then so all these points look symmetrical. And so then you just graph, do the best you can. Do the best you can. It looks something like this. Okay, so there's your graph. All right, 17, you're now graphing an exponential function. Remember, this is exponential. Exponential function. So remember, an exponential function is where the variable x is located in the exponent. Now remember, exponential functions have a horizontal asymptote, and that horizontal asymptote is this constant right here. So remember, y equals b to the x plus c. So c is your horizontal asymptote. And remember, the horizontal asymptote is a horizontal line. So when we found the axis of symmetry, which was the vertical, the axis of symmetry was the vertical line, we name a vertical line using x equal. We name a horizontal line using y equal. So we say y equals a -4. Now let's just go ahead and draw this asymptote right now. So y equal -4 is here. So I'm going to draw my horizontal line just like this. All right, and then let's go ahead and find the y-intercept next. So to find the y-intercept, you're going to let x equal 0. So if I let x equal 0 right here, if I let x equal 0, I'm going to get y equals, so y equals 3 to the 0. Remember, x is 0, minus 4. Now remember, 3 to the 0 is 1. 1 minus 4 is a -3. So there's my y-intercept. So my y-intercept is -3. Okay. Now remember, we talked about this before, so some of these things we're about to talk about can help you draw this graph. The base here is 3. So remember, the base is bigger than 1. If the base is bigger than 1, the graph increases. So the graph increases. So this thing should be increasing like this. So it goes towards the horizontal asymptote and then increases rapidly. So let's just pick a couple more points. So if x is, let's say, 1, if x is 1, I get y equals 3 to the first minus 4, which is 3 minus 4, which is -1. So 1, -1 is here. So that's -1. If x is 2, I get y equals 3 squared minus 4. So that's 9 minus 4, which is 5. So I get 2, 5, and 2, 5 is right here. All right, and then it's going to connect the dots. So remember, it's rising rapidly here. It rises rapidly, and then on this side, it goes towards the horizontal asymptote. All right, so my y-intercept is -3. Say -3. The domain, remember, the domain here is, you got to go along the x-axis. The domain here is all real numbers, so from -infinity to infinity. The range, though, is different. The range is not all real numbers. So I'm going to go along the y-axis. So remember, these y values are getting closer and closer to what y value? Well, they're getting closer and closer to -4. But it is never -4, but it gets closer and closer and close to it. So when I talk about the range, I can say -4 to infinity, but I cannot use brackets because, so it's got to look like this, because these y values, none of these will ever be -4. It gets closer and closer and closer to it, but it will never be -4. For instance, it'll get to, let's say, -3.9, -3.99, -3.999, -3.99999, and so on, but never -4. And so there's your graph. Okay, number 18. All right, 18 is where you start using those compound interest formulas. And so monthlies, so that's a finite number of compoundings, and then this is continuously. So for this one, you're going to use this formula, a equals p times 1 plus r over n raised to the nt. And then here, you're going to use a equals p times e to the rt. So if it says compounded continuously, then you use the one with the base e. And then basically you're just going to round to the nearest cent. So so you're going to plug in these values. So remember, the 12,500, that's your initial amount. So how much would be an account in which you initially invested $12,500? So you're going to say 12,500 here times 1 plus r. R is 3.5%. Now be careful, don't put 3.5. You must write 3.5 as a decimal. So remember, to change a percent to a decimal, you move the decimal point 2 places to the left. So this is 0.035 divided by n. N is the number of times it's being compounded per year. So since it's monthly, n has to equal 12. All raised to, in parentheses, nt power, so n is 12, times t, and t must be in years, and it is here, so that's 5. And then basically you're just going to use your calculator. So you're going to say this. Just punch in what you see. So you say 12,500. So 12,500 times, in parentheses, 1 plus 0.035 divided by 12. Close the parentheses, but you got to raise that to a power. So you got to use this. You got to raise it. See this exponent right here. You got to raise it to, in parentheses, 12 times 5. 12 times 5. Close the parentheses, and then press equal. And so to the nearest cent, remember the nearest cent means 2 digits behind the decimal point, so the hundredths place. So to the hundredths place, it's going to be $14,886.79. So since the thousandths is 5 or bigger, the hundredths, you got to add 1 to it. So the 8 becomes a 9. So you're going to get $14,886.79. All right, for continuously, you're going to say A equals P, which was the original amount, so 12,500, times e to the r. R is 0.035. You got to change, remember, you got to change your percent to a decimal, times the time, which is 5. And then just use your calculator. So you're going to say 12,500 times e. Now to get e, you're going to press second ln button, so that gives you your e. And your exponent is 0.035 times 5. So 0.035 times 5, close it, and then press equal. And so you get $14,890.58 this time. 58 cents. Okay, so in number 19, and also notice that, remember, this is being compounded a finite number of times, so only 12. This is being compounded continuously, so an infinite number of times. So you would expect this number to be bigger than this number. It's not a lot bigger, but it is still bigger. Okay, so over here you want to write this log equation to an exponential. So what you have to remember was this. If you have, let's say, y equals b to the x, let's say, y equals b to the x. You can convert this exponential to its equivalent log form, and the equivalent log form is this: log, this base is this base, and so remember we're saying b to the x, so you got to say equal x, so b to the x, and this y is your argument. So you have to use this in order to be able to think about these a and b here. So this is in this is a log equation. It's in log form. You want to write in exponential then. So the exponential, this base is the same as this base. You can say 4 raised to the 7th power equal x. All right, so that's how you write that. Now you're going backwards. So you're giving exponential, you want to write as a log. So you can say log, this base is this base of the log, so that's a 3 here. So 3 to the x, so you can say equal x, and the argument is this number here, 21. So always check, 3 to the x equals 21. That's what this is. 4 to the 7th equals x. That's what this is. All right, now remember, you can only take the log of a positive number, so that's what this part C is about. So you can only take the log of a positive number. So when we talk about the log base m must be positive. M must be positive. So this argument here, x minus 4, must be positive. And so you find the domain, you just got to solve for x. So x is greater than 4. So that's your domain. So in terms of the interval, though, because it did say write an interval notation, you're going to say 4 comma to infinity. All right, over here, you want to use your properties of logarithms. So remember, you're going to use, in this case here, you can use a quotient rule. So the quotient rule says I'm going to write this as the difference of 2 logs. So you can use subtraction. So you're going to say the log base 3 of y, subtract, because it did say calculate expressions without using a calculator. So let me do that here. So that's a log base 3 of y, subtract log base 3 of 3. Now this is where you got to remember the log base 3 of 3, that's just 1. 3 to what power is 3? Well, 3 to the first power is 3, so that's a 1 here. So here's your answer. So log base 3 of y minus 1. Over here, you use a product rule and the power rule, but you got to use the product rule first. You can't put the 5 in front, because in order to put the 5 in front, this whole thing has to be raised to the 5th, and it's not. Only this x is. So you have to use the product rule first. So it becomes log base 2 of 16 plus log base 2 of x to the fifth. And now I can use a power rule with this. And I can also simplify this. 2 to what power 16? Well, 2 to the fifth power 16. Plus, and then pull the 5 on the front, this becomes 5 log base 2 of x. So that goes here. 5 plus 5 log base 2 of x. Okay, 22. This is where you're solving this rational equation. And so you've got to first of all find your restrictions, and basically let's factor this first. This right here, when you factor x squared minus 6x plus 8, you're going to get x minus 4 times x minus 2. And you can always check yourself. X times x is x squared. The outer is a negative 2x. The inner is a negative 4x. A negative 2 and a negative 4 is a negative 6. And then a negative 4 times a negative 2 is a positive 8. And so your restriction, for each factor, you got to find out what makes this factor 0. That's how you find your restrictions. Because remember, you cannot divide by 0. So what makes x minus 4 0? Well, x minus 4 is 0 when x is 4. What makes x minus 2 0? Well, x minus 2 is 0 when x is 2. And we already took care of x minus 4, and we already took care of x minus 2. So there are two restrictions. So x cannot equal 4, and x cannot equal 2. Okay, so now remember, to solve this rational equation, I got to multiply both sides by the LCD. So I got to find the LCD. So the LCD is x minus 4 times x minus 2 in this case. And so I'm going to multiply both sides by this LCD. So I'm going to say x minus 4 times x minus 2 times the left side, like this. And then the LCD, x minus 4 times x minus 2 times the right side. So 2 divided by, and then I'm going to use the factored form. Okay? All right, and then I'm going to distribute here. So all of these fractions in here have to be multiplied by the LCD. So x minus 4 times x minus 2 times the first fraction plus the LCD, x minus 4 times x minus 2 times the second fraction. And that's going to equal, now on this side, I'm just going to go ahead and divide these out right away. So these x minus 4s divide out, the x minus 2s divide out, and you're just left with 2. Okay, let's go ahead and simplify these. See, this x minus 4 reduced with this x minus 4. So you're left with x minus 2 times 1, which is just x minus 2. Plus, these x minus 2s divide out, but this time, though, you got to be careful. You have x minus 4 times x, which is x times x minus 4. That's what you have here. So this right here is this, equal 2. All right, now you got to clear these parentheses here, so you can distribute. So I get x minus 2 plus x times x is x squared, x times a minus 4 is a minus 4x, equal 2. Now notice that this is quadratic. This is quadratic. So I got to solve this quadratic equation. So I'm going to combine like terms first and put in descending order. So this is x squared. A positive x, and a negative 4x is a negative 3x, and then minus 2 equals 2. So this right here, when combined, is this. Now I'm going to remember to either solve by factoring or to use the quadratic formula. I got to have 0 on the other side. So I'm going to subtract 2 from both sides, and so I get x squared minus 3x minus 4 equal 0. Now you can notice that this is factorable, so this is easy enough to where you can see that it's factorable. So you can factor this as x times x is x squared. So I want the last to be negative, so it means one's positive, one's negative. And I need the inner to be negative 3. I mean the outer and the inner to add up to be negative 3. So the only way that works is if this is x minus 4 and this is x plus 1. That's the only way that works. You can always check yourself. The outer is a positive x, the inner is a negative 4x, and when I add them up, I get a negative 3x. That's equals 0. So now I'm going to use the zero factor property. So I said each one of these is equal to 0. All right, and when I say each one equal to 0, I get x to be 4 and x to be negative 1. But remember, I can't use 4 because that's a restriction. When x is 4, this becomes 1 divided by 4, which is undefined. All right, so that's called an extraneous root. Extraneous root. So remember, extraneous root or extraneous solution. So basically, it satisfies this quadratic equation, but it doesn't satisfy the original, the rational equation. So that's extraneous root. So that's what that means. It's a false solution. So it satisfies one of these, but it doesn't satisfy the original. So the only one that works then would be x equal -1. So that would be your answer only. Now, you see, we factored. So if you wanted to, you could have used the quadratic formula. You could have used quadratic formula. So in this case, if you use quadratic formula, a is 1, b is -3, and c is -4. C is -4. And so we get the opposite of b, so the opposite of -3 is a +3, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is -4, all over 2 times a, and a is 1. So that equals 3, plus or minus the square root of -3 squared is 9. A -4 times a +1 times a -4 is a +16, all over 2. So that becomes 3 plus or minus the square root of 25, all divided by 2. The square root of 25, 25 is a perfect square, so the square root of 25 is 5. So 3 plus or minus 5 divided by 2, and then you split it apart. That becomes 3 plus 5 divided by 2, and then 3 minus 5 divided by 2. So 3 plus 5 is 8. 8 divided by 2 is 4. So that's what we found here. And then here, 3 minus 5 is -2. We divide by 2, which is -1. And that's what we got here. And so remember, we can't use this. This is extraneous right here. So we can't use it. So we got to use this only. So this is the only solution. Okay? All right. And then finally, the last page, this is where you had to evaluate these without using a calculator. And all you're doing there is using that property, changing this to an exponential. So remember, you're saying here, right here, you're saying 5 to what power is 25. Remember, a log is just an exponent. And that's what we talked about. So 5 to what exponent is 25. Well, 5 squared is 25. So that's a 2. Here, remember, the ln means log means log base b. Log base e of e. So this right here is this. So this is ln e. So ln e is the same as this. So then we got to figure out what this is. So e to what power is e? Well, e to the first power is itself. So that's 1. Here, same thing. You're going to say, remember, there's no base there. It's going to be 10. So that's a common logarithm. This right here was a natural logarithm. So log base 10 of 1,000, that's what this is, equals what exponent. So you say 10 to what exponent equals 1,000. I'm sorry, that's 10. 10 to what exponent equals 1,000? Well, 10 to the third power is 1,000. Again, here, that's log base 10. So you say log of 1. It's the same thing as saying log base 10 of 1. So say equal some exponent. So 10 to what exponent is 1? Well, remember, 10 to the 0 power is 1. That's 0. Here, you're saying log base 6 of 6 to the 4th power equals what exponent? Well, 6 to the box, 6 to what exponent is 6 to the 4th. Well, that's where you can use the one-to-one property. So when the base is the same, that means the exponents have to be the same. So this has to equal 4. And the same thing here. Natural log of e to the 5th, right here. So remember, the natural log of e to the 5th means the same thing as log base e of e to the 5th. So we're just trying to figure out what this exponent equals. So e to what exponent equals e to the 5th? Well, just like this, we're going to use a one-to-one property. So the base is the same, the exponents have to be equal. So the exponent here has to be 5. Okay, so that was test 3. So hopefully this key will help you. If you missed anything, this key will help you to figure out what concepts you misunderstood, and hopefully you now understand a little bit better. Okay, so that's the end of this this test.